Write the balanced molecular equation for the neutralization reaction between H2SO4 and KOH in aqueous solution. So the tricky part here is that we need to first understand how H2SO4 would even have to neutralize. So we have H2SO4 plus H2O, okay, and it is a strong acid actually, the first one, or is it? I was confused. Sulfuric acid is actually, yes, it is a strong acid, the first one. So it dissociates completely to where it gets H2SO4 minus plus H3O plus. And then that HSO4, okay, plus H2O turns into SO42 minus plus H3O plus, okay? That is the steps it will take for SO4 to get rid of all the protons. Now KOH just turns into, and this would just be like that because it's a weaker acid, but KOH is associated to K plus and OH minus. So in order for this to actually balance out, okay, we have 2 H3O. This OH minus has to happen twice. And that would be the only way, because in this case, we need the 2 OH minus to neutralize the 2 H3Os. So we would actually have, and if we wrote this whole formula, these two would cancel out first, and then everything else will stay. So we have H2SO4, okay, plus 2H2O plus, right here, 2, well actually we can just write this part because they are dissociated in the water, but here 2K plus 2OH minus turns into, and then we have these two here form the K2SO4, okay, and then now we have 2 OHs plus 2OH minus plus 2H3O plus. And actually together, these two are actually just 2H2O. So with that being said, now we have 2H2O here and here. So really, what we have in total, just to make sure, K2SO4, spectator ions, thing, just to make sure, 2H3O plus 2K plus 2OH minus K2SO4 plus H. Okay, just to make sure I have it correctly done. We have 2H3O, 2OH. Oh, I see where. So instead of this, we would actually have, so we have the 2H3O, yes, but the OH minus is still going to be there as well. And as well with the, so this is where the H pluses are, H3O. Oh, okay, I definitely miscounted. There we go. So we have 2H3O plus O minus. So to get to H2O, 2K to 2OH. So that would be in total. I want to make sure I write this right, because if I take two, oh, okay, I see what's happening. 2 hydrogens can go over there. So that in total we have 4H2O. That is what I was missing there, because these two don't just form 2H2O. We have 6 hydrogens and 2 oxygens here, and 2 hydrogens and 2 oxygens here. So to balance out to 4 and 2, you have to move 2 hydrogens over there. So that's why we have 4H2O liquid. And now we can actually see here, The 2 cancels there, and then the 4 becomes 2. So what's left over in the equation is H2SO4 plus 2 potassium. And don't forget your aqueous sign. Okay, plus 2 OH minus aqueous turns into, and what we have left is K2SO4 aqueous plus 2H2O liquid. And as you can see, this will be balanced because we have 2K replacing the 2H, and so that's why we can get the 2H2O, because we have 2 OH minus, just need a proton. And let's see how we did. So this is the first, just writing everything out, and this would be not balanced quite yet. So now after they balance it, they have 2K and 2 OH, and then they got the K2SO4 plus 2H2O liquid. Perfect. So this is going to be the balanced equation, and this is correct. And the only reason why I wrote the K and the OH separately, just because for strong bases, they dissociate completely. So that would be theoretically what would be in the solution. We have potassium ions and hydroxide ions. And then technically would have H2SO4 ions and H3O, but that would be a little bit complicated. So question number 13.